Good morning, friends. Today we are discussing Buckingham's pi theorem in dimensional analysis. In Rayleigh's method, what we have seen earlier, so the Rayleigh's method is depending on only maximum of four variables. When the number of variables exceeds four in the given problem, so it is very difficult to follow Rayleigh's method. So then we have to follow Buckingham's theorem. Let us take a numerical and see how Buckingham's pi theorem follows. The resisting force R of a supersonic plane which is having depending on the length of the aircraft L, velocity V, air viscosity mu, air density rho and bulk modulus of the air K. So it is asked to express the functional relationship between these variables and the resisting force R of the plane. Now, the Buckingham's theorem's first step will be like this. So, writing the dependent variable in terms of independent variable. Now, the resisting force R of the plane is depending on these five variables, that is length of the aircraft L, velocity of the aircraft V, air viscosity mu, air density rho and bulk modulus K. So the same relation will be rewritten like this. So F1 of R comma L comma V comma mu comma rho comma K, that is there are six variables here, so that will be equated to 0. So number of variables n is equal to 6. Number of fundamental dimensions, that is length, mass and time are the three fundamental dimensions. So m is equal to 3. So number of dimensionless pi terms. Sorry. In this problem, so the number of dimensionless pi terms will be used n minus m. So that is number of dependent and independent variables together is 6 and m is the fundamental dimensions, that is 3. So in this particular problem, number of dimensionless pi terms will be 3. So thus there will be 3 pi terms which we are writing it as f1 of pi 1 comma pi 2 comma pi 3. So that is equal to 0. So if we have 4 pi terms, so then we will have pi 1 comma pi 2 comma pi 3 comma pi 4 is equal to 0. Then step 2, each pi term contains m plus 1 variables where m is equal to 3 and also one repeating variable. Out of 6 variables, that is which is listed earlier, so there will be 3 variables which are selecting as the repeating variables. How to select the repeating variables? So since R is a dependent variable, it cannot be repeating. Out of the remaining 5 variables, so one should represent the geometric property, second variable should have the flow property and the third will have the fluid property. Out of these 5 variables, that is L, V, mu, rho and K. So L represents here the length, that is the geometric property. So you can take length, volume and area as geometric properties. Now here L is representing the geometric property and V, velocity of the fluid, will be considered as the flow property, and out of mu, rho and K, which are representing the fluid properties, so you can take randomly any one of these three. Now step 3, we are writing the three pi terms here. Each pi term will be having 3 repeating variables already discussed. So L, V and rho, so are representing the geometric property, flow property and the fluid property. The rest 3 variables I am writing each one of the 3 remaining variables in each pi term like this. So each pi term is solved by the principle of dimensional homogeneity. In the sense, First we'll take the first pi term, so that is pi 1. So the geometric the fundamental dimensions L, M and T. So since pi 1 is not having any fundamental dimensions, their powers are 0 comma the length is having the fundamental dimension 0, M is having the fundamental dimension, so that is its power is also 0, and T's power is also 0 on the left side of the equation, because pi 1 is a term which is having no fundamental dimensions, so their powers are 0. Now in the first term, that is pi 1, I have L to the power of A1, V to the power of B1, rho to the power of C1 into capital R. So for L, so the fundamental dimension is capital L. For velocity, so it is meter per second. So it is written as L by T. So that will be written as L T to the power of minus 1 to the power of B1. So then density, so it is mass by volume. So mass is in M, volume that is in L cube. So it is M by L cube, which is written as M L to the power of minus 3 to the power of C1, and R resisting force. So force will be having equation. So M into A, F is equal to M into A, mass that is written as M, acceleration L T to the power of minus 2. So M L T to the power of minus 2, equating the powers of L, M and T on both the sides. For L, the power is 0 on the left side. On the right side, I have L to the power of A1, then L to the power of B1, L to the power of minus 3C1 and L to the power of 1 here. So that is taken as A1 plus B1 minus 3C1 plus 1. Similarly for M, it is written here, and T also it is written here. On solving, I am getting my A1, B1, C1 values here. Substituting A1, B1, C1 back into pi 1 term. So it is L to the power of A1 is minus 2. Then V to the power of B1, so that is minus 2, rho to the power of C1, so that is minus 1 into R. So I am getting my pi 1 equation. Similarly, so I am writing my pi 2 equation. So then solving for my powers A2, B2, C2, substituting them in pi 2 term. So I am getting my pi 2 here. Then pi 3 term is taken here. Their powers of fundamental dimensions is written on the left side, having the power 0. Then the powers of this L, V, rho and K will be written here. Equating the powers on both the sides, we are getting A3, B3, C3, substituting them back. Then I have f of pi 1 comma pi 2 comma pi 3 is equal to 0. Then R equation for resistance of the supersonic plane will be written in terms of the other variables. Thank you, friends.